Professor Dave and Chegg here. We've learned about some reactions that alkynes will undergo. So let's look at a few more, specifically some possibilities in terms of reduction.
When we say reduction in the context of pi bonds, we are talking about hydrogenation, as we are reacting with hydrogen to remove those pi bonds. We already know that we can do catalytic hydrogenation with an alkene using molecular hydrogen and some metal surface, like platinum or palladium. This will also work with alkynes and will result in an alkane just like it did when we used alkenes. The alkyne will approach and one equivalent of hydrogen will add, giving us an alkene, and then that alkene will approach and another equivalent of hydrogen will add, giving us an alkane. So the technique we already know works just fine here. But what if we want to stop at the alkene and not go all the way to the alkane? We will have to use another technique. In fact, there are two that we must learn. First, let's look at these reaction conditions. We have hydrogen and we have palladium metal that has been treated with something like calcium carbonate, which limits its ability to react such that it can only react with alkynes and not alkenes. And because the hydrogens are both coming from the same solid surface, this will be a syn addition, just like we originally saw with hydrogenation of alkenes. This will result in a cis or Z alkene as the hydrogens are added to the same side of the molecule, so these alkyl groups will end up on the other side of the double bond. This reagent is referred to as Lindlar's catalyst, and we will associate it with generating a Z alkene from an alkyne. Since we have a way to get the Z alkene, we will also want a way to get the trans or E alkene. We can achieve this with these reaction conditions. These will include a group 1 metal like lithium or sodium in elemental form, as well as an amine like ammonia. And these conditions will result in an E alkene. So if you're doing some synthetic chemistry and you want to go from an alkyne to an alkene, these are some strategies that you can employ to get alkenes in a stereospecific manner so that you can get the alkene you want. To make sure we have this, let's take a look at this starting material with 3 different reaction conditions listed. We will want to be able to recognize these reaction conditions and know what will happen to the alkyne in each case. Going this way first, we know that the conditions we used previously to hydrogenate alkenes will take the alkyne all the way to the alkane, so we just lose these pi bonds. Next over here, we see Lindlar's catalyst, so let's draw the corresponding Z alkene, and then right here we see the other set of conditions, which will bring us to the E alkene. We should make sure to draw the correct geometry for each of these, as is required for sp2 carbons.
So we now have 3 ways to reduce alkynes, either to the alkane or to the Z or E alkene, depending on our intentions. Professor Dave for Chegg. See you next time.